Welcome to Walkabout the Galaxy, the #1 podcast in the world. Don't Google that. Where the science is universal, the opinions are personal, and it's the OG hosts coming to you.
Woot!
We
That's
are
right.
Strange, Charm, and Top, the astroquarks, also known as Josh Caldwell.
Addie Dove.
Jim Cooney.
Coming to you from the Walkabout studio at the University of Central Florida. Subscribe to us on Facebook, Instagram, and YouTube. Downquark, Audrey Martin is on the other side of the globe right now.
She is.
Whoa.
If you haven't seen it already, check out the astroquarks song on YouTube. It's still that same old.
Oh, there's not the new one.
The new one hasn't happened, but hope springs eternal.
Sure. We have an idea for the third one, so...
Yeah. Check out the astroquarks song. If you have seen it, watch it again. You can contact us at wtg@ucf.edu with questions, suggestions, and compliments. Our stumper today is inspired by dark matter.
Ooh. Which we've discussed a few times on recent episodes.
Different dark matter.
Oh.
This is the show Dark Matter on Apple TV Plus, which is inspired by the book. Or I shouldn't say inspired by, it's based on the book and like basically created by the author of the book. So it is, although I haven't read the book, I'm assuming pretty faithful to it. And it's it's very well done. It's a pretty cool parallel universes science fiction thing. First season.
Oh.
I'd be curious to see if there is a second season. It's a self-contained season,
Okay.
but there could be a second season. Basically, the idea is that you could. So it sort of relates to Schrodinger's cat, and the idea, and there's a very good Veritasium. I don't know. For me, it's very good because I can kind of understand it. There's a Veritasium YouTube video about parallel universes, and he talks to at Caltech.
I love O'Shoot at Caltech.
It's so good.
He's really good. He's really good on
top
camera.
of his game, and he really knows about parallel universes. And there's a universe where I don't forget his name.
Sure.
And Sean, maybe. Carroll.
Sean Carroll.
There you go.
And
he's more of a... Yeah, okay, that's probably him.
And the idea is that, like the Schrodinger's cat thing is, you can have a quantum system of a radioactive nucleus that has some probability of decay. And if it does decay, it emits something which triggers release of poison, which kills the cat in the box. And if it doesn't, the cat is alive. And there's this, how do you interpret what is actually going on inside the box? Because quantum mechanically, it's a wave function with probabilities of different situations. And now the cat, this macroscopic system, is entangled with this microscopic quantum system. So the cat is existing as a superposition of his dead and living self. Anyway, the concept of dark matter, the show, is somebody builds a box that is completely isolated from the outside world.
Okay.
And then when you step into it, you are then existing in a superposition of all possible states.
Well, so when you step out of it, you
So
can
when you step out of it, you step
state.
into a different
Is
universe.
it Quantum Leap?
No.
Okay.
Yeah. It's a little grimmer than Quantum Leap. And so basically, it's a kind of a cool, thing to set up a thing where people can go into this room, and then when they step out, they're in a parallel universe. And how do they sort of figure out how to navigate between those parallel universes and what all that's like? So this is a good. I enjoyed the show.
Okay.
And
cool.
It's on my list.
That's the inspiration for our stumper.
I finally watched Dune.
And longish.
Yeah. Anyway, let's do our stumper. Then we can do some...
The stumper is, if you could go into such a box and step into a parallel universe, but it's different from this universe in only one way. Only one thing is different. What would you like to be different about that universe? You'd step in to a new universe. You got to be careful because, it's the whole universe you're talking about. So if you, if you say, I want gravity to be a little bit less, well, think about what that means for the atmosphere on the Earth, for example, or whatever, so.
I think I would like it to be able to communicate with my cats.
You would like for people
Two-way
to be able two-way communication
between
with
cats and people.
Okay.
Sure, why not?
I bet There are reasons. We could come up with reasons why not.
Well, I know. You'll hear all about their murder thoughts, I'm sure. But...
Right. They'd be, instead of just meow, meow, or looking, glaring at you, they'd be going, give me food, you.
Yeah, that's what my daughter does. So.
Yeah. Jim, what about you?
Jeez.
I still like it, though. I like it.
Thanks.
I like it, yeah.
It seems more innocuous than changing gravity.
Yeah.
Yeah, I was going to make myself a little taller. But
it's not really what one thinks of when one thinks about changing the universe.
No, it isn't. It
It
isn't.
changes his universe immensely.
Yeah.
Yeah. Well, it's like you said, I don't want to mess things up for other people.
Right.
But I was also thinking about some fish that I lost. That broke the line many years ago, and man, I wish it wouldn't have happened. These seem like very silly, selfish changes.
I like Addie's answer better.
better.
Yeah.
At least something. Yeah.
Why? What are you going to do?
I think.
I don't know. I mean, I'm kind of liking dog conversations.
Sure. I mean, maybe we could do something where, interstellar travel is more easy to accomplish. There's a more direct...
Oh, yeah.
We're in a universe where it's well established enough that there's highways kind of things that's more direct. That we're born into that universe.
Can we do things like change, make the speed of light 60 miles an hour?
I feel like that would go...
You could do that.
I feel like that would really screw
Be careful.
some stuff up.
Be very, very careful. I mean, that could be your
That's
universe.
so slow.
Can we do it where the Earth is flat?
Yeah.
That
Already
already exists, Jim. Hey, can I just say,
Yeah.
still haven't seen that model.
Yeah.
Right.
Yeah.
Yeah.
Well, it turns out it's harder than I thought.
Okay.
That's what she said.
Talking to dogs, or maybe it could be something just sort of like fusion energy is working.
Sure.
Oh, yeah.
I like that.
Yeah.
I mean, it's working somewhere, but...
Fusion energy reactors. Are working.
Yeah. They'd come about 60 years before they do.
Yeah.
Unless we save
they
ourselves
already
from
are
climate
working.
change.
Yeah.
Yeah.
Yeah, 60 years ago.
Yes. I go to a universe where fusion reactors were invented and promulgated across the globe in 1850.
Nice.
I love it.
Okay, well, today we'll talk about Cygnus X-3, Furbies, and much more. But first, this episode of Walkabout the Galaxy is brought to you, not coincidentally, by Schrodinger's cat.
Meow.
Having a bad day, things aren't going your way? Lock into a different part of your wave function with Schrodinger's cat. Simultaneously alive, dead, freshly dead, long dead, intermediately dead, and all other kinds of dead, because that's what wave functions do. Change your reality with Schrodinger's cat. Every pet deserves the best life.
A fresh pet.
Yeah, mix.
Purina. I'll give it to you, both of you, although I've never heard of Fresh Pet, but I'm assuming.
Like one of the fancy new ones that's refrigerated and stuff.
We had a whole bunch of exciting space news weeks ago. It seems like it's sort of slowed down a little bit into kind of humdrummy stuff. Starliner is still kind of, I don't want to use the word stranded.
It's not stranded. Do not use that word.
I would never use
well, because CNN and other people have been using that word, and that is not the correct word.
Why?
It is completely functional.
Right.
It is completely functional.
It is up there.
It is still up on the ISS.
They have delayed its return.
Yes, and part of that is to do more studying, and part of that is it actually makes sense within the program of what's going on up there, of when their spacewalks are happening, to keep them up there a little bit longer. Uh-huh. One of the big challenges, right? So part of the reason it's up there longer is that they're trying to figure out some of these leaks. So there's been these little helium leak detected, and they've had issues with thrusters. The reason they really need to do that as much as they can while it's up there is the thrusters are on the service module. The sort of rocket part beneath the living quarters. Yeah, so it's like a ring that has service features, and it's not the capsule. So that module doesn't come back. So they can't. It burns up in the atmosphere. It separates and burns up in the atmosphere. So they cannot bring it back and study it.
They won't be able to do diagnosis of what's wrong with it once they come back.
Yeah. So that's why after the first flight, we knew there were some anomalies, but they weren't able to diagnose it. But now it's up there. They can put it through its paces a little bit more. They can do more things to try to understand why they're having the issues they're having.
I see.
So it's actually really useful to have it be on board for longer.
Right. So.
And they could stay most of the summer, and it would be fine.
Yeah. For Apollo 13. The equivalent of the service module was the big command module. Yeah. At the top of which was the little gumdrop living quarters that the astronauts resided in, and the problem was
I think it was called the service module. I think the gumdrop was called the command module.
Oh, okay.
I'll check.
Yes. Thank you. So, right, the rockety part.
Yes.
Let's get technical here.
Well, the rocket
There's
part
the people
separates.
part and the rocket part.
Yeah.
And the problem was in the rocket part.
Yes.
And they didn't, just as you were describing, we didn't get the rocket part back with Apollo 13.
The service module.
Of course, there was a sort of more of a life and death situation where it's like, well, we're not so worried about diagnosis after the fact.
Yeah.
Here, it's not life and death, and so there's this diagnosis issue, and they need to do that. Cool.
And
I
like
wasn't
they're
aware of that.
actually pretty they have a big crew complement up there right now, and they I saw some statistic, and I wanted to look up that number again, but it's like, yes, they have these little tiny helium leaks, but like, I don't know, helium's just gonna leak. Right? Like, it is so tiny.
It's this big.
Just
right.
it's really easy to leak. And the amount of like fuel they have available to come back is something like 700 times what they need.
So
or 70. I forget which order of magnitude, but it's more than an order of magnitude of like what they need to come back. So there's been all this like, everything's terrible. So that's why I got upset when
that was what I was thinking too. Everything is terrible, but not because of the helium leaks. I had been convinced before that was a non-thing or not big issues. It's the thrusters. Because what if don't they have to be able to?
So it was 5 of
get back
28
down
thrusters failed when they were trying to dock, and 4 of them came back online. So it's 1 of 28 that they have an issue with.
And how redundant are they? Like how?
They're RCS thrusters, so they're like fairly redundant.
What the hell is an RCS?
Those are just the little like positioning thrusters. So
right,
they're fairly redundant.
It's not the main engine that puts you on the trajectory for your reentry.
Okay.
Yeah.
Okay.
Yeah.
So at this point, now that they're up there, those are not that relevant because they can.
They'll need them to like position for reentry, and they have enough fuel for all of that. But it's not like they don't have enough fuel to get back.
I think Jim's asking, do they have confidence that they will be able to accurately steer the ship to the appropriate reentry?
I haven't seen anything where they've been like
willy-nilly. You have to reenter carefully.
I have seen statements from the NASA folks who have said, like, if we need them to come back today, they would come back on that vehicle. So, like, they could do that.
Okay.
Yeah.
Okay. I'm just saying, I'd be nervous.
Yeah.
If 5 failed before, what if 10 fail this time?
Yeah.
You're nervous about the speed of light being faster than 60 miles an hour.
Yeah.
So.
Also, though, there was supposed to be a spacewalk this week, and there was a coolant leak in one of the spacesuits.
Oh.
And then, like, 2 weeks ago, when the day before they were supposed to be doing it, there was some, like, panic because on one of the YouTube or on, like, NASA TV or something, they had like, they were testing out some scenarios on like a ground loop, and it accidentally got into the feed that like external people were listening to, and it was like they were testing out panic scenario kind of things, and people were like, "Oh my God, there's an emergency on the ISS," and it was, but then the spacewalk got canceled the next day, and then it's also had a coolant issue the following time, so it's like weird things happening.
Leaks are horrible, and they're
so
just
common.
all the time and everywhere. My dishwasher's leaking, so
My
we have
shower
to get
leaks.
a new dishwasher.
Yeah, I mean, you guys, that's pretty life and death.
Yeah.
Do you have to get a new dishwasher? You can't just like replace the seal? I mean, you have a pretty old dishwasher, so.
It's just so we went through this analysis.
Is this something we actually care about?
The analysis went like this. How much time would it take me to get a new dishwasher, and how much time would it take me to fix the dishwasher? And that determined the solution.
Sure.
Other space news.
There was a GOES launch on a Falcon Heavy.
So that's very exciting.
Yesterday.
GOES stands for?
Global Observation of the Earth and Sun. I made that up.
I don't think
but
that's
it
right.
I
sounds
kind of like it.
convincing.
Yeah.
That is
It's a
not
weather
correct.
satellite.
No, it's
a weather-
geostationary operational environmental satellites.
Well,
Yeah, these are
like
NOAA.
yours.
I got the letters right.
You did. This is the NOAA, National Oceanic and Atmospheric Association, which was a Jeopardy question the other day.
Ooh.
I know. I
One
saw
person
that
got it
one.
wrong.
But these are
Satellite
super
launched
important.
on a Falcon Heavy yesterday.
And what does the GOES U do? So GOES satellites do
This is
things
GOES
like
U.
map, cloud cover and
Well, you don't map
infrared
cloud cover because it's always changing. You observe it and you
Right.
track it.
Well,
The GOES,
yeah.
the GOES data is like
is that not what I meant?
It may be what you meant. It's just not what you
different.
said.
It's a different term. For folks who look at like the NOAA hurricane stuff and watch Tropical Tidbits or other things, they often use GOES
all the time
satellite data to show us what's happening in the infrared and in different wavelengths. And GOES, there was when they were getting this one ready for launch, there was I had listened to a good talk on NPR somewhere from somebody who was like working on these satellites, and they are like these giant like bus. They're like Cassini size or bigger, maybe. They're like
I'm sure they're bigger.
Full bus size satellites kind of thing that have like 17 instruments or something on them. They're these massive. I had no idea. They are massive.
Big telescopes and big instruments and observatories.
Yeah. So like they needed a Falcon Heavy to put it into orbit. You need a big booster to get it up there. And it goes into geostationary orbit. And this is GOES U when it's launched, but it gets renamed to GOES 19 once it's in orbit.
What?
Yeah. When they're on the ground, they have a letter. And then once they're in orbit, they're a number.
Well, that just makes sense.
Yeah, I know. You wouldn't want to be confused about ground or satellite. I don't actually remember why it does that.
And so if you like to know, whether a hurricane is coming or things of that nature, it's important that this kind of work continues.
Yeah. So they do weather observations and environmental monitoring. So like a bunch of different wavelengths, real time, lightning, space weather, also some space weather stuff. So they have like things that map the ground and then also what's happening around the satellite. So like incoming sun and space weather stuff. I think they have a solar ultraviolet imager, extreme ultraviolet and X-ray sensors, a coronagraph.
So she said map. Why didn't you yell at her?
Sorry?
She said map the ground. Why didn't you yell at her?
The ground, you can map the ground. You can't map clouds.
Yeah, I also agree that this lightning mapper is a weird term.
Oh, lightning mapper? Yeah, I don't.
They used it. Oh, God damn.
All right. Yeah. Anyway, the next flight of the SpaceX gigantic thing may be coming in July, and they are threatening that they will catch the booster with the chopsticks. So this will be something to see for sure.
Booster with my chopsticks.
So that would be something to see too. So the giant rocket
Karate Kid
has these arms at 90-degree angles that will reach out and catch this giant.
The launch tower does.
The launch tower.
Yeah.
That will reach out and catch the booster when it comes back, and then I don't know whether they have said that they'll also try to bring the upper stage back. I don't think that's been mentioned. The Starship itself back, which has previously been demonstrated to do soft landings the same way the Falcon 9 boosters do, but not after a flight to space, just after some low altitude flights. So that'll be interesting to see. They've been upgrading their heat resistant tiles on the Starship because they had a kind of a burn through event on the last test where the Starship was re-entering, and it did some burn through. So that'll be interesting to see coming up.
Hopefully not on the Starliner.
Shortly. And then there's news from the moon.
Yeah.
Yes, I have questions.
Okay. So the news is that we mentioned that the Chang'e 6 mission, which is a Chinese space agency mission, landed on the far side of the moon in a region called the South Pole Aitken Basin, which is a very scientifically interesting region on the moon. It's this big, giant, old impact feature that is like probably hit so hard that it made this it's just this massive feature. It's like a third of the surface area of the moon or something. Whoa. And so it probably dug down really deep. So it exposed like mantle and subsurface stuff that we can't get to elsewhere. Anyway, it landed over there. Really interesting. And it brought back samples.
How much?
And it landed this week. Ooh, that is a great question. I don't know if I've seen that number.
Order of magnitude? Like a few grams or a few kilograms?
Yep.
I'm guessing somewhere in that range.
Yep.
Somewhere in
between.
between.
Narrowed it down to 3 orders of magnitude.
Okay, fair enough.
That's my guess.
Yeah.
Up to 2 kilograms.
Oh, that's a lot. Yeah.
Expected to have returned up to 2 kilograms.
So this is very exciting. So unfortunately, obviously, we're in. We have our governments are not getting along well currently, but are scientists getting along well? Do we get some of that? When I say we, I mean scientists in the
Around the
U.S.
world.
and the EU and places like this.
So just recently, there was a call for proposals where U.S. scientists could propose to use the Chinese samples from the previous return. So they did one return already from
also the far side?
No, it was from the near side, but further south. And so they're... But I don't know if any of those have been selected yet. So it's like one of these things where like NASA was like, yes, you may propose for this and we will figure out how to make it happen kind of thing.
Okay.
So they're still working through a lot of that.
But it's not NASA's. Yeah, it's not NASA's decision, right?
So
It's
typically
space.
with these missions, so like with the Japanese Hayabusa missions, right? NASA was a little bit a part of that mission. So we have exchange agreements with JAXA and with the U.S. And like we're going to provide OSIRIS-REx samples to JAXA and a few other space agencies, like European space agencies. And so typically those agreements are in place. With the Chinese, obviously, it's much more complicated, but they do have like a database that lists the samples, and you can look at pictures of them now, and you could do that when you were proposing. So I think that there's an anticipation that other folks will be able to use these samples, but
Yeah.
We'll see. Okay.
Jim, before we jump out into the cosmos, you have prepared a top quark trivia.
I have one planetary thing too, but we can talk about it a different time.
All right. I have 2 simple questions for you.
Okay.
Because we came up with this just before the episode.
Okay.
The first one, I think you guys all know the answer to this,
He's doing
but
this without notes.
I remember
Yeah, it's quite impressive.
years ago.
It's a sign of an experienced educator.
Yes. And this is yes. So years ago, myself, I believe Eddie Dove was there as well, went to a trivia night.
Oh.
And it was a space-themed trivia night, and we thought, oh, we're going to
Dominate.
kick butt because it was us and a handful of other astronomy kind of people. And one of the questions was this,
easy?
and I think you know the answer to this, but there's a follow-up,
Okay.
which is just this, simply this. What is the most dense planet in the solar system?
Okay.
Now, I'll tell the story about what happened at that space trivia night when we get the answer.
Okay.
But your secondary question, which you can be thinking of as well, is, because I think you know the answers to the first one, is what is the most dense moon in the solar system?
I feel like this was recently at Astronomy on Tap.
That I have no idea. I don't go to that. But that one I thought was harder.
Could you? I'm
Sorry,
just
my
wondering,
coffee cup
Could
was
you get
really-
a noisier coffee cup?
Should I get more ice cubes in my coffee cup?
And noisier coffee?
I could.
Really? I want to hear that.
Grind the beans.
I want to hear.
I could get more ice cubes in there and go.
I want to hear a
I could
noisier.
chew my ice
A
cubes.
noisier coffee.
Okay.
The densest moon
The
in
densest
the solar
planet
system.
and then the densest
No
moon.
moon.
Okay. But
No,
not-
obviously, but yeah.
Okay. And not only will I answer those 2 questions, I will also tell you the densest star in the solar system.
Nice. Very good.
That we know of.
That we know of.
One thing really quickly before we move out of the
Yes.
solar system. When we were flipping through articles earlier, something caught your eye on my screen, and it was, you were like, oh, is that Uranus's rings?
Right.
And I said, no, it's satellite mega constellation tracks.
Yeah.
And it gets worse.
So let's first explain what a
explain what it
satellite
is.
mega
So the
constellation
image,
tracks
the
are.
image to our dear listeners is a black and white image, rectangular in
sky.
shape of the sky, but it just has like sort of diagonal lines across it and sort of distribution. So like to us, it's maybe like, oh, that looks like a ring system.
Right.
And there's some like white spots in the background, stars, things like that. And Josh said, oh, is that a ring system?
It looks like a famous Voyager picture of the rings of Uranus.
Yes, but instead the caption reads, an astronomical image marred by trails caused by satellites of SpaceX's Starlink mega constellation.
Yeah.
So this is one thing, and this is something we've talked about before. Like, this is a problem, but it's actually been less of a some of it's less. They've been working on ways to mitigate it. It's only really, really bad if you look just after sunset, when it's
Right.
when they're super glary, things like that. But the actual bad thing is this article is actually about a new study that just came out in which people did some simulations of what's happening from all of the satellites that are re-entering. So with these
Oh.
SpaceX mega constellations,
They
they
don't
put
live
them
very
up into
long.
orbit. They last years
crazy.
maybe,
Yeah.
and then they're low enough that they lose
Orbits
their
decay,
orbits
yeah.
and they burn up in the atmosphere. That's putting all of those chemicals and all of that
to the
stuff into
environment.
the environment. And so this is potential ozone depletion.
And pulverized.
Yeah.
I mean, it's one thing. It's like, you take your satellite to the junkyard. It's like, okay, that's bad in that one room.
Right.
Yeah.
Figuratively speaking of the junkyard. But if you're like, I know what, let's pulverize this into, its constituent molecules and then distribute it over a large area of land or sea.
And I feel like
those
we've
aren't
talked a
all
lot
nice
about
molecules. Those are mean.
And folks have talked about like launch vehicles causing pollution. But this is that you have, especially they did this study on aluminum oxide nanoparticles, because you get a 250 kilogram satellite can generate around 30 kilograms of aluminum oxide nanoparticles, which may endure for decades in the atmosphere. And these are really great for seeding things that cause ozone depletion.
Interesting.
So
Cool. Well,
that's cool. So
it is,
yay,
because this
Uranus
morning
is
I was
sorry.
like, you know what I need? Something else to worry
Something
about.
else to another reason to think about ozone depletion again. We were it's been good lately.
Yeah.
We were like, it's better than we thought it was a few years ago.
Yeah.
Okay. Well, I'm glad that's over with.
Yeah.
Jim, take us out to the cosmos.
Cygnus X-3.
Cygnus X-1, you mean?
Nope. I mean Cygnus X-3. You know of Cygnus X-1.
I do.
It's super famous. Why?
No,
Super
X.
famous is maybe.
Yeah, it's a visible remnant of it's an X-ray. It's the first
Oh,
X-ray. Something.
Something.
Supernova. Astrophysics.
what is it, Jim?
Where is it? It's in the constellation Cygnus.
Yeah.
And it's the brightest X-ray source in the constellation Cygnus, thus the name Cygnus
Why-
X-1.
Why were you scorning at
Why does
me
Cygnus
when
have
I
so
started
many
to say it was
X's?
an X-ray source?
No, I wasn't.
Yes, you were.
That's just his resting scorn face.
Yeah, I'm
Resting
just
scorn face.
It's famous because it is the first kind of observationally detected black hole. So Cygnus
X1
X1 is an X-ray binary system. So there's a main star and then an unseen secondary star that is extremely bright in X-ray. And when we calculate its size and the only thing it can be is
the thing that's going around it is moving so quickly on such a tiny orbit
Right.
that it has to be the mass of it has to be a black hole.
right. It has to be a black hole. So and this wasn't, of course, satisfactory to everyone. You could still not believe in black
I was
holes.
I was
after this.
satisfied. Though.
Right, and many people were. And X-ray brightness is how we found a lot of the first black holes. But anyway, so that's a.
That is hard to satisfy, though.
It's true.
But Cygnus X-3 is a thing also.
Why are there? So
I don't know
many,
what Cygnus
why are
X-2
there-
is, to be honest.
That's what
Why are there so many X-ray sources in Cygnus? Are there lots of others?
Cygnus is
in other
generally
places,
there is in the plane of the Milky Way. And thus there are
Lots
going
of
to be
stuff there.
a higher density of interesting things in those directions.
So we're skipping X2.
We're skipping X2, which I don't know what the heck it is. But Cygnus X3 is another bright X-ray source.
Cygnus X2 is a song by Rush.
Seriously?
Yeah.
Neil Peart.
Oh, it has a neutron star. Okay, sorry. Continue.
Cygnus X2 does. What does Cygnus X3 have?
It also is
X-ray
a
binary.
X-ray binary.
Also an X-ray binary.
We think.
But strangely bright. And
I get that comment a lot.
yeah. But it's interesting because X-ray binaries are like little mini versions of what's happening in the centers of giant galaxies.
Well,
I love
wanna,
a good mini version.
I want to clarify what you mean by X-ray binary.
Sure,
Sometimes we talk about binary typically means two things that are bound to each other, typically gravitationally. So
I
it
thought
could
you were just
be
going to stop at two things. A binary typically means two things.
two things, 1 or 0. For example, a binary star system means two stars that are orbiting each other.
Mm-hmm.
Then when we put a qualifier in front of it, like sometimes we'll call it a spectroscopic binary. And that means that the way we know it's a binary is not because we see two things, but we see the spectra of two things.
right.
So what is meant by X-ray binary? Does that mean it's two things that we can see are separate and we see them in the X-ray? Or is there something about the X-ray signature that tells us there's two things there?
No, it's you see two things. At least one of them in the X-ray, right, and one of them in the visible.
You
or
don't
something
always
else.
see the other thing if it's a black hole.
So you're seeing the black hole in X-ray because there's an accretion. So basically, the black hole is stealing material from its partner. The partner is typically seen, right? You see the partner in visible or something else, and then it has an unseen partner. Say unseen, invisible, but it's there in X-ray because it's stealing material from its partner and has this accretion disk.
Okay. So these are binary star system that's bright in the X-rays.
Right. And
Bright in the X-rays would be a really good rock song title.
Bright in the X-rays. But there are kind of rules to how bright these accretion disks should be able to be. There's a thing called the Eddington limit,
Yes.
which you probably learned about in an astrophysics course at some point.
I did. It's even sponsored the show, in fact.
Yeah, that's right. I vaguely remember that. But the idea there is, if you get really, really, really bright, then photons, light itself, has pressure associated with it. And if you get too bright, then
you blow yourself apart.
Blow yourself apart. And good job drinking that coffee without disrupting the show until right now. And so anyway, these Cygnus X-3 appears to be much brighter than it should be able to support.
Does that mean that because both of them are creating brightness?
No, it must be because they think
it's brighter than the Eddington limit.
Brighter than the Eddington limit. So this must indicate that there's some weird way in which you're producing more X-rays than you would just from the glowing hot gas. So it's like being beamed or something like that. And basically the thing that's going on is like you make this accretion disk, and towards the center of it, it's like a funnel kind of a shape, like the inside of a donut.
You love a funnel cake.
So freaking much. Thanks for reminding me. I haven't had a funnel cake in...
we should go to Halloween Horror Nights and get funnel cakes.
Let's go get a funnel cake.
That's what I remember about you.
After the show, we're getting a funnel cake.
Okay.
And it turns out if you have an X-ray, you have this bright gas in there, you can bounce the X-rays off of the inside of this funnel.
What?
And that kind of collimates the X-rays in a little bit. And polarizes them, by the way, which is how they determined this is going on. They looked at the polarization of the X-rays and found that they are polarized, which indicates that they're being reflected off of some surface.
Right, but if they're reflecting off the surface, they're imparting momentum to that surface, which would blow it away. So I don't understand how this helps overcome the Eddington limit.
So it's not...
Oh, it's because
it's
not
the actual thing
actually
is not over the Eddington limit. You're just seeing extra X-rays in that direction.
It's not uniformly distributed.
Correct.
All those photons are not coming out from a spherical 4 pi steradian.
Right.
They're concentrated in a certain area. And if you said, if I extrapolate that over the whole...
Right. Then it would be
over the Eddington limit.
That's correct.
So the reason I'm seeing such a high thing is because it's beamed in this particular way.
Right. And this is like a mini version of what can happen in these big supermassive black hole accretion disks in the centers of galaxies. And it's nice because those things are happening really, really, really far away. And sometimes it's hard to figure out what's going on. And this is like a little mini laboratory.
That's fun.
For understanding the physics of what's happening there. So fun.
And its outbursts are intermittent because it has a Wolf-Rayet star around.
Right, which is in an elliptical orbit around they're in an elliptical orbit around each other, which means that it's
sometimes it's close and interacting strongly and stealing a lot of material, dumping a lot of material into the accretion disk.
The Wolf-Rayet star is a star that's like near the end of its life, and it's blowing off significant material from its surface. That's great food source for your accretion disk
black hole. Right.
And of course, it makes it a little bit irregular because these stars typically, you're not blowing off material at a constant rate. You're blowing it off in fits and starts. And when you combine that with an elliptical orbit, things get
speaking of variable stellar activity, there's an exciting piece of space news that's relevant to these stellar remnants that we want to just remind our listeners about.
Yeah, I don't remember when, but a few episodes ago we talked about this nova that is about to explode.
Oh,
and
man.
And we this time we really do mean sometimes we say Betelgeuse is about to go supernova sometime in the next million years.
Yeah. Right.
But this is sometime in the next million seconds.
Yeah, sometime this
or so.
Probably this summer.
10 million seconds.
It's going to be a T Coronae summer.
So is this...
That's the name of it. T Coronae Borealis is a recurrent nova. And it had a blast in 1866 that astronomers observed. I did not observe it. Also in 1946.
Thanks for that clarification.
Well, I was saying we at first, and it meant the royal we astronomers.
Yeah, right.
So its period, it was also 1946, so its period was like 79 or 80 years.
Right.
And it's 3,000 light years away. And so we're observing it, and it has already undergone a pre-eruption dip in brightness. So about 1 year before it blows up, it has this dip in brightness. And that's the dip in brightness. And so they're saying May 2024 plus or minus a few months. So we're in the plus side of this. So
sometime in the next couple of months. So just remind us, this is a star. And it's going to have an explosion that will not destroy the star, which is one of the distinguishing characteristics between it and a supernova, right? So the supernova is a brighter phenomenon that results in the destruction of the star, and the leftover is typically a neutron star or a black hole.
Yeah.
A nova is less super.
It is less super. This is generally when a white dwarf is orbiting another star and stealing material from that other star. That material, which is hydrogen basically, collects on the surface of the white dwarf and eventually gets dense enough and hot enough to start nuclear fusion.
As though it were a star.
As though it were in the core of another star. But now, but it's on the surface of this thing, so it's like naked fusion kind of.
Right.
And when it starts, it happens very quickly.
Naked fusion would be a great name for a rock band.
Yes, it would. Naked. Yes, it would.
I hope they're listening.
Rock bands?
Yeah.
Future rock bands.
Future rock bands. So this material burns off brightly and quickly, and it can radically increase the brightness of that system up to like 100,000 solar luminosities, like a lot.
Right.
But only for a little while, for a few days,
right.
something like that, until it burns through that hydrogen, and then that hydrogen's gone, and you just have your white dwarf again. And so it doesn't really disrupt the system.
Yeah.
The white dwarf's now just a little bit more massive, and on we go to
so the white
round.
dwarf are the remnant of our sun. When it finishes doing its main sequence lifetime, will be a white dwarf.
It will be
something about the size of the planet Earth with most of the mass of the sun.
Right.
So a very, very dense object.
Right. Crazy.
And because of that incredible density, that's what enables this to happen. You put some raw fuel of a fusion reaction on the surface, there's this incredible gravitational pressure on it, which can cause it then to fuse. In a regular star, that would be coming about from the tremendous pressure of all the overlying material.
Right.
Yeah.
Right.
But which would also be concealing it, that radiation from coming out, which is why we just sort of have one solar luminosity coming out from the sun.
Exactly.
So that's exciting. So we'll need to be paying attention to
Here's
the
my
news.
one question about this.
You can go look tonight, for instance, and look at Corona Borealis and look and see this.
So is it currently a visible? Like, is it a visible system now? Because of course that name Nova comes from
new star.
Right, comes from Stella Nova, which was Latin for new star. Because a lot of times these things will be not visible to the naked eye, and then visible to the naked eye when they do this thing. I don't know if is this one.
It's not visible right now,
but it will be when it goes
nova.
It's
then it is a true the North
nova.
Star. It's going to be a second magnitude.
That's a bright star.
Yeah,
nice.
It should be one of the brightest nova for generations.
Oh, well, tell me when it happens.
Its magnitude is 10
currently.
Okay.
Yes.
Okay.
And 6 is about the maximum for
what we can
minimum
see.
Or whatever.
You really need a really dark sky to be able to see that.
Right.
Yeah. So cool.
Stay tuned.
All right. Let's come back to our trivia.
Talk to me about density. We just talked about very dense things like white dwarfs. What about planets? This is the first one is the easy one.
Yeah, I know, and I always get it wrong.
It's easy, but it's also kind of a psych out question.
That's right. I ask this of my intro astronomy students all the time, and they get it wrong for the right reasons, which is great.
Well,
Earth.
Mercury.
Yeah, the correct answer is Earth.
Damn it.
Yep.
And this is what happened at the trivia night. Is the majority of people, including Dr. Addie Dove, said Mercury.
Yeah.
And I said no, only because I was teaching astronomy, intro astronomy at the time. It's actually Earth because
Earth is so big compared to Mercury.
Right. Everybody thinks Mercury because, like, if you show diagrams of what it is, its iron core is much larger percentage of its entirety.
Yeah.
Well, but the listeners
I think we've even had this as,
we've discussed this before.
Yeah. And I was just like, Is it Mercury or is it a psych out thing?
It's a psych out thing. It's a psych out
but
thing.
But then you do it like 3 times and then you end up back at Mercury.
Yeah. But the real reason is, right, big, Earth is so large that it compresses its interior. So its core is just denser than Mercury's core. Anyway, that's the...
Right. But like Jupiter is even bigger, but it's much less dense.
Right.
Yes.
Right.
Because of the composition. So,
right. Exactly. So, but they're very close, but it is... Okay, so what about moons? What is the most dense moon in our solar system? I don't think I would have known the answer to this. I know what I'm going to guess. I said the wrong answer first last time, so I'm going to have Addie go first this time.
No, I said the right answer first last time.
I spoke first last time.
No, I did.
Doesn't matter. Addie, give me your answer.
I said Mercury, and you said Earth after I said Mercury.
The moon.
You?
No.
You said
Addie
Earth
says
before I said
roll the tape.
Moon. Doesn't matter.
Doesn't matter. The moon.
The moon.
Matters to me.
Okay. Which answer do you want?
I'm going... I think you're probably right, but I'm going to say Io.
I like that.
In fact, it's Io. Good job, Dr. Caldwell.
Right,
excellent work. Excellent. Yes, you split them. You're both geniuses today.
Yeah.
That's excellent. Yeah. I don't know why I didn't have time to research what.
Because of its
What
density.
do you mean you didn't know why?
Well, I mean, meaning like, what is it? Is it a compositional? I mean, it must be a compositional thing because it's not.
It's not.
But I don't know. Like, I don't know. I don't know fundamentally
It
understand
formed
why.
in a high temperature region.
Yeah. So it has
And
to be
the moon
rock
formed
stuff.
from the lighter elements that were knocked off the proto-Earth in that giant collision.
Right.
Whereas
It has
Io
an
presumably
irony.
accreted in a sort of high temperature accretion disk region where
I'd be
volatiles
curious
weren't available.
For
as
the
much.
Galilean moons generally, like what their density range is. I don't know.
Well, the outer ones are much cooler forming, and so they have ice, so they're lower density.
Yeah, I think that Io has a much higher density than any of the other moons in the solar system, which I wouldn't have guessed, but Josh obviously would have and did.
Yay! Good job. Retribution.
Yes, or some sort of
That's not the right word.
something. I know what you mean.
Thanks.
While it may have felt like being Schrodinger's cat, it was just another episode of Walkabout the Galaxy. Give us 5 stars, and we'll give you the universe.
Be sure to follow us on Facebook and Instagram to get all our updates. Subscribe to our YouTube channel and catch up on old episodes wherever you get your podcasts.
Our theme music was composed by Richard Jurusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in Taiwan and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the astroquarks signing off until the next episode of Walkabout the Galaxy.
I don't have anything today. My mind just went blank.